and this is decreasing function as well, and irrespective of the presence of transient spikes, the yearly infections decrease, and decrease in the mean yearly infection with increasing proportion of newborns vaccinated is higher for the higher vaccine efficacy. So we got these three results, and then we thought that okay, we have done these things with one model. Now these results may be specific to the models, so we do two things. We consider two models. One of them was simpler than the model we chose, and one of them which was a bit more complex model for dengue than what we had. So the simpler model assumes that there is no secondary infection. So out of my equation, when I had 4 unvaccinated class and 4 vaccinated class, so I have now only 2 unvaccinated class and 2 vaccinated class. So we see that in that case also we have transient spike, and this is just one example where we show that there is transient spike, but the nature means the kind of result we got for that model, we got similar results for this model as well. For the complex model, we incorporated that hypothesis of short-term cross protection. So saying that by short-term cross protection we meant that means you have a temporary immune period after you come out of your first infection, and that in that temporary immune period you don't get infected even if you get bitten by a mosquito with another serotype. So we had to add 2 more compartments with it for this, and we also incorporated in this model one more assumption, that was when you get secondary infection, your risk of getting the disease means there is enhancement in transmission. So we did that by just increasing the course of infection by a factor of 1.1, and we still get the transient spike in that case. And again, our results were similar to what I had shown for these models as well. So my summary for this project is that introducing a dengue vaccine may lead to a transient period, provided the vaccination rate and vaccination efficacy are not very low or high. Second is that presence of transient spikes are sensitive to the time of vaccine introduction. And then the third fact is that presence of transient spikes not necessarily mean that your vaccine program is ineffective. And finally, in the long term, irrespective of the fact that the limit cycle do change, the average number of infections per year decrease with the increase in vaccination rates as well as efficacy. Now, what can we say using this to the public policy people? First thing, that transient spike appeared to be very robust phenomena of seasonally posed disease. So I showed it for dengue, but we believe that other seasonally posed disease models, means other models with like other disease which actually follow the seasonally posed disease model, these transient spikes do appear there as well. So while making the vaccination program, the possibility of these transient spikes should be taken under the consideration, and more specifically, the policymakers or public health departments should be prepared to mitigate the immediate burden of these spikes, and moreover the resulting perception of inefficacy of the vaccine program. And then finally, probably for mathematicians like us, one should try to design a vaccine program that not only minimizes the initial burden, the short-term burden, but also minimizes the height of the initial amplitude, so that the transient spikes are not very high. So that means the burden will not be really bad. So this was the presentation. Thank you very much for listening.
Go ahead.
Can you give an intuitive idea of why, after the vaccines are produced, you expect spikes to occur?
So, just by the model, we have seasonality. We have 2 time scales now. So there is 1 time scale, and then my course of infection now is seasonal, right? So because of the mosquito abundance, there is seasonality in the model, and that because of that seasonality model, we have these 2 periods. And when we introduce vaccine, what we are doing basically is we are perturbing the system. So this new system will again converge somewhere, but there will be a transient period before that. So we suspected that during that transient period, there is possibility that that incidence will rise higher than what it used to before. Does that answer your question?
You mentioned other similar diseases. Do we have data that shows a similar kind of effect?
So most of the disease, couple of diseases which they use. So we saw something similar in like very old measles startup, but on the recent, some recent disease, the vaccine efficacies were generally very high. So we don't see those trends, but like we do see from some very old data. And also, actually, we saw it in some plant disease. And I think that's where this idea came to us, because with plant disease, you can actually kind of experiment on the plants, not at human. So this was something, that idea came from there, and we thought, okay, this is possible with these diseases as well, and that's what we found from symposium. Third question?
That was actually my question,
Okay.
involving, because it seems to me like it would be very restrictive to the kinds of ways that it's transmitted, or is that not the case?
Can you repeat that, please?
It seems like it would be very restricted to the ways in which the disease is transmitted, or is this not the case?
So means, I don't understand your question. So you mean the presence of transient spike?
Yes, the effectiveness of the vaccine,
Okay.
and the pattern that it follows.
Mhm.
Is that would that be different for a disease that had a different mode of transmission?
And I think that's what we were trying. Means generally, what I'm saying is that if something is signally poor, we should expect something like this.
Okay.
Because the basic phenomena will be the same. It's the thing which I told him, that you perturb the system and then you expect that period would be same. So means only place where I would expect that there should be nothing like this will be when we are considering no signal no signality in the model. But we from literature we kind of knew that dengue is like highly signal disease.
Okay.
So we were quite sure that probably we'll find this in this disease. So we took this one as an example. And also because it has very complex dynamics, so we could have possibility of choosing from simpler, complex, and choosing from a range of models.
And in this model, you're assuming constant birth rates, and so that
Yes.
you're constantly constant
Yes.
percentage of these newborns are getting vaccinated
Yes.
in the period.
But we did actually check these results. Means we did not do all the analysis for everything, but we did check with some models on long term. By that I mean that making the birth rate to be proportional to something, and then death rate means making the population growing. So we made those assumptions as well, and we find something similar there also. Any other questions?